Hey guys, it's Harper here. So a couple of you had I've had multiple questions on binomial PDFs and binomial CDFs. So this is an additional video to hopefully help you understand binomial PDFs, CDFs, and when to do 1 minus binomial PDF or CDF. 1 minus binomial PDF you won't do very often. This one right here, it's going to be almost never. So let me get an annotation device. There we go. So let's do this first one. When do we do a binomial PDF? For all of these, let's use an example of rolling 12 dice. Okay, so we're going to roll 12 dice. I want to know what's the probability that exactly 4 of them are going to be a 1. Exactly. That word exactly. You can do this. I believe you, computer. This is harder than it looks, writing on your screen. Just saying. Exactly is going to be a keyword whenever you're doing a binomial PDF. Exactly this many will be. Exactly this many will be. Okay, so exactly 4 dice will be a 5. Exactly 2 dice will be a 3. That's when you use a binomial PDF. Now, if there's a word not in there, what's the probability that exactly 5 of them will not be a 3? That's when you're going to use 1 minus PDF. And the keyword there is going to be not. Okay. Or it could be no or none, something along the lines of that. Okay, not, none, no. Exactly, specifically. I'm trying to think of other synonyms that could work for exactly. That's when you're going to use a PDF, when it's exactly. If there's the word not exactly, or there's not this many, there's not a specific number, that's when you're going to use 1 minus binomial. Okay. Now CDFs, a CDF stands for cumulative distribution function. This is just a probability distribution function up here. Okay. This is cumulative, meaning that it adds them together. So back to the example of the dice. If I want to know what's the probability that there are at most, what's the probability that there's at most 5 6s when you roll 12 dice? That would be a binomial CDF because it's cumulative. It adds up. If we're saying at most, that could be 0 6s. It could be 1 6. It could be 2 6s. It could be 3 6s, 4 6s, or 5 6s. Any of those would be correct answers. There's multiple correct answers, all spanning from 0 up to a certain number. That would be a CDF. Okay. Now, from 0 to that number is a CDF. From anything after that number would be 1 minus a CDF. So at least at least is when you use 1 minus binomial CDF. So if we want at least 5 6s on a roll, so we've got our 12 dices, we jumble them up, roll them on the Yahtzee table. We're going to try to make $1 million here. And it comes back that, oh, you know what? We're sorry. You only got 4 of them. Or hey, maybe we get 7. Okay? But we're trying to get at least 5. Well, 5 would be acceptable. 6 would be acceptable. 7 would be acceptable. 8 would be acceptable. 9 would be acceptable. 10 would be acceptable. 11, 12, any of those would be acceptable. A 2 wouldn't be acceptable if we want at least 5. All right. How do I get rid of those annotations? Clear all. There we go. So let's try another one real quick. Let's try this example here. You have a 70% chance of making a shot. If you're Harper Smith, you have a 0% chance. So you're playing some basketball, shooting some hoop, woo, and you got a 70% chance of making them. What's the probability that you will make 7 out of 10? Now at this, it's not saying exactly, it's not saying at most, it's not using those exact words. But out of these words here, what does it make us think? Does it make us think we want to make exactly 7 shots? Do we want to make at least 7 shots? At most 7 shots? We do not want to make 7 shots? Well, think about it. We want to make exactly 7 shots. We will make 7. That is an exact number. So that is going to be a binomial PDF. Okay, this is going to be a PDF. When we plug that into our calculator, I'm going to do on second distribution binomial PDF. And I'm going to move this a little bit so we can see it a little better. How many total shots are we going to make? That's the first number. How many trials? 10, comma. What is the probability of making each shot? 0.7. And what is the number of shots we want to make? We want to make 7 shots exactly. Okay, that's how I'm going to plug into the calculator. Now let's look. What is the probability of making exactly 7 shots? 27%. 26.7%. Okay. All right, so let's try the next one. You have a 70% chance of making a shot. What's the probability that you will make at least 7 out of the 10? All right, if we're going to make at least 7 out of the 10, let's make a numbered line. Okay, you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Horrible spacing, I know. 10, 9, 8, 7. All right, so we want to make at least 7. So what numbers could we be getting? 7, 8, 9, or 10. So is this going to be a CDF or a PDF? Is this just one number that we're looking for? Or is it a accumulation of multiple probabilities? Is it just one probability or accumulation of multiple probabilities? In this case, it's accumulation of multiple. It's accumulation of these 4. So if it is accumulation of multiple probabilities, that will be a CDF function, okay? And this is going to be CDF. So let's do the math here. Now the trickiest piece is going to know what binomial CDF accumulation are you going to need to calculate? What CDF can we calculate? Your TI-84s can't do 7 to 10. They can do 0 to some number. So do we want to do 0 to 7? No, we don't want to do 0 to 7. We only want to do 0 to 6. All of this is going to end up equaling 100%. So if we know what this probability is, 0 to 6, 1 minus whatever 0 to 6 is going to give us 7 to 10. So if I plug that into a calculator, okay, we're going to do variable distribution of a binomial CDF. We're going to do 10, comma, 0.7, comma, we want to make at most 6, close the parenthesis. It's going to be about a 35% probability for 0 to 6. So if I want to know 7 to 10, if this is 35% from here to here, that's 35%, then this over here must be probably about, what would that be, 65%? Let's look. 1 minus that answer, 65%, okay? So this is a 65% chance. Let's try one more, okay? I want to get rid of my annotations. I apologize, I'm still getting used to this. All right, let's see here. The probability of a new car tire. Let's do one of these. I'm just gonna do one. The probability that a new car tire, will do that first one, okay? Let's see if I can figure out how to move this. There we go, okay. So the probability that a new car tire lasts throughout the warranty period is about 80%. So when you buy a car tire, it comes with a mileage warranty. My car, for instance, it's rated, the tires I got are rated for 70,000. I'm at about 35,000 and they're basically already shot. They're gone, okay? So I can take them in and wherever I bought them, we'll warranty them. I bought them at Walmart. Wherever I bought them, we'll warranty them and I can get some new tires Usually they won't warranty 100%. Sometimes they'll just do a prorated. So since I used half the tire, they'll give me half off of whatever I paid for the tire, if that makes sense. So in this case, the probability that a tire lasts through the warranty period is 0.8 for a specific tire. That would have been nice for the tires I have, because all 4 of them are basically gone. What is the probability that all 4 tires last through the warranty period? It doesn't tell us how long the warranty period is. And the nice thing is we don't need it now. How many tires total are we working with? 4. Okay. Do we want to know at most 4 last? Exactly 4 last? We want to know exactly 4. So that'd be a binomial PDF or binomial CDF. If it is exactly 4, it would be a PDF because that is exactly 4. So let's grab our calculator. We're going to do a distribution. We have 4 tires. Okay, that's what we're sampling. Comma, there's an 80% chance that they make it through. Then how many tires do we want to make it through? Exactly. How many successful tires do we want? We want all 4. What's the probability that all of them make it? About a 41% chance. That's kind of sad, to be honest. You have a 40% chance, 41% chance that all of your tires last through the warranty. It means that over half the people have to go in before the warranty's up and get their tires switched out. Anyway, hopefully this helps. If you need more help, please let me know. I'll do more videos. I'll probably do them on the whiteboard next time if you need more help. See you guys.